the functions y1 equals e to the power x, y2 e to the power 2x, and y3 equals e to the power 3x. The solutions of okay. Now find the general solution. I found the general solution. So we're gonna follow. Basically, we're gonna follow 4 steps. So first step, we're gonna calculate the Wronskian. Okay. After we're calculating the Wronskian, whether that guy equals 0 or not, we can determine whether they are linearly independent or dependent. Right. After we check the linearly independent or dependent, we're gonna check whether they are form a fundamental set of solutions. If they are form, then we can do the linear combination of this solution. We're gonna get the general solution. Okay, so go ahead, do it by yourself. The key part is gonna be a Wronskian. Okay, the key part will be a Wronskian. One more minute. Okay, now I'm gonna write down the answer on board. So the first step, you're gonna calculate the Wronskian. Right, Wronskian of these 3 functions. And the Wronskian gonna be the determinant of these 3 laws. right? So the first law, we're gonna copy it. And the second law gonna be the first derivative. And the second law gonna be a second derivative. Right? And then we can simplify it. So for the first derivative of exponent function gonna be itself. If we do the derivative of this guy, we're gonna get e to the power 2x. Do the derivative of this guy, gonna be 3 times e to the power 3x. And again, second derivative. This is the first derivative, right? If we do the second derivative for this guy, that means we're gonna do the derivative again for the second row, okay? We'll do the derivative for the second row, and derivative for e to the power x is gonna be equal to self. If we do the derivative of this guy, we're gonna get 4e to the power 2x, right? This is a composite function. And if we do the derivative of this guy, we're gonna get what? 9, right? 9 e to the power 3x. Okay. And then you can use the expansion, right? That's what we learned from linear algebra. Probably you can you already noticed that we already applied such a method to learn the calculus 3, right? Calculus 3. Calculus 3, we do the expansion, right? Expansion. And we do the expansion of this guy. All right. And we're gonna do the expansion of the last term. Okay. After you got this one, that means cross product. Okay, cross product, and you can calculate it by yourself. The answer for this guy gonna be 2e to the power 6x. Okay, 6x. So this guy doesn't equal 0. That means we can get the following conclusion. Linearly independent. 3, y1, y2, and y3 form a fundamental set of solutions. And 3, 4, y equals c1. It's the general solution. Okay, so this is a fundamental set of solutions. Why is that? Because 3 solutions corresponding to third derivative, right? We have third derivative, third order differential equation. Okay, so 3 solutions, third order differential equation. So 3 third, right? So that means form a fundamental set of solutions. And then after we know that form a fundamental set of solution, we just do the linear combination. And then we can get general solution. Okay, that's it. That's it. That's what we learned from last class. Okay, so if we get the general solution for the homogeneous equation like that, homogeneous equation means right hand side equals 0. Now, how to find the general solution for non-homogeneous equation? Let's take a look. Theorem. Six. General solution. Non-homogeneous equations. Let 1p be any particular solution of non-homogeneous equation when on I. Okay, the non-homogeneous equation I R1 is like that. Let me check the solutions. It looks like that, right? I put it in your previous notes. So an x divided over dny dxn plus an minus 1x equals gx. Okay, and I should give you guys the general non-homogeneous equation for nth order differential equation before. Okay, you can check your previous notes. That's the non-homogeneous equation 1. Okay, that's so let y1, y2, yn be a fundamental set of solutions of homogeneous equation. Okay, equation 2. That means let the right hand side equals 0. That means right for homogeneous equation. I the general solutions of equation 1 is what? Y equals C1 y1x plus C2 y2x plus Cn ynx plus yp. Okay, so how to find the general solution for the non-homogeneous equation? We just do the linear combination of this solution, and this solution is the general solution of equation 1 or the solutions of homogeneous equation. And we say this part is 1c, right? 1c. Where the Ci I is 1, 2, blah, 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 n arbitrary constants. So that's the formula. Okay. So next time, if you find the homogeneous equation of the solution for the homogeneous equation, so how to find the solution for non-homogeneous equation? Just let the homogeneous solution plus a particular solution. Okay, that will be the general solution for non-homogeneous equation. Okay, now let's take a look. The example 3. We found, for example, we know YP particular solution that is -11/12. Subtract this guy is a particular solution of okay. So based on the theorem 4.16, right? We need the homogeneous solution plus a particular solution, right? For this case, I already gave you the particular solution. How about the homogeneous solution? The homogeneous solution or homogeneous solution means what? Means this guy equals 0, right? This guy equals 0. Find the solution for this guy equals 0. What does that mean? That means this equation, right? This equation, and we know the homogeneous solution for this equation going to be the linear combination of these three solutions. Oh, sorry, this is 2x. This is 3x. Okay, that's the solution for the homogeneous equation of here. Okay, or this guy equals 0, right? This guy equals 0. It's exactly this guy. Right? We know the homogeneous solution is going to be this guy. So we can write down like that. We found the homogeneous equation, just copy it from the last problem. So the general solution for the particular, for the non-homogeneous equation going to be YC plus YP, right? And that will be this guy plus particular solution will be copied. That's it. And this guy is the general solution. Okay, general solution. That's it. Very, very straightforward. Very, very straightforward. If I already gave you the particular solution, what are you gonna do? Just combine the homogeneous solution and the particular solution together. Okay. Now let's move on. For general case, if I give you one solution for the first order differential or second order differential equations, in order to find the second solution, we can use the following formula. Okay, for general case, the standard form is the second solution y2x y1x y1x squared dx by giving the first solution. y1x. Okay. By giving the first solution, how to find the second solution? We can use this formula. Okay, use this formula to find the second solution. Then if we find the two solutions, then we can do the linear combination. And after we do the linear combination, we can get the general solution for this homogeneous equation. Okay, homogeneous equation, because here is a second order, so we need two solutions, right? Second order corresponding to two solutions. So we already have one solution. Through this formula, we find the second solution. Then do the linear combination, we're gonna get the solutions for this homogeneous equation. Okay, now let's take a look. The example. Example 1. y1 equals x squared is the solution of find the second solution y2x and general solution. Okay. Now let's take a look. This equation, x squared y double prime minus 3x y prime plus 4y equals 0. Okay, for this guy. And as we can tell, this is not a standard form. Standard form is like that. Right? Be careful, it's a standard form. So it shall be keep the coefficient of the second derivative equals 1. So here is x squared. That means we're going to divide by x squared for both sides. So we have divided by x squared for both sides. Right? And then we can tell the px is what? Px equals negative 3 over x. Right? Px corresponding to this term. Now we can calculate the derivative. Okay, the derivative of px. Here we can plug in, and of course we can calculate this guy equals ln x. Okay, ln x. And here I don't put the constant because the formula don't requires in the formula just want us to find one solution is enough. Okay, if you put constant here, you're gonna have the infinity solutions. So for this case, because we're gonna do the linear combination for the y1 and the y2, we're gonna automatically add the constants. So when we do the integral, we don't add the constant. Okay, we just needed to find one solution. Okay. So after we got that, now we follow the formula. All right. we have y1x is what? X squared. And this guy is a negative 3x. So negative, positive 3x. Y1 is x squared. Do the square again. And this guy, we're going to simplify it. So e ln x cubed, x power 4. Continue. X cubed, x power 4 dx. Simplify it. And we're going to get ln x. Right? We got the second solution gonna be x squared times ln x. Okay, so now linear combination of these two. So now we have constant here, right? Constant here. So C1 is what? C1 times x squared. C2 times x squared ln x. That is the general solution. Okay, that's the general solution for this guy. Okay, now I'm gonna give you guys an example. Let you guys try it by yourself. Okay, try it by yourself. Basically, we're gonna use this formula, right? Use this formula to find the second solution. And of course, you need to do the integral, right? You need to do the integral. After you find the second solution, you're gonna do the linear combination. That's it. Okay, try this one. Example 2. Find the general solution. Hint. If you do the integral of 0, that is a constant, right? It will give you a constant, right? An integral of 0 equals a constant. Because you do the derivative, you're going to get a 0. Integral is the reverses of the derivative. So integral of 0 equals constant. You can let c equals 0, right? So for this case, you can just keep a special case. Found one solution, let c equals 0, okay? So go ahead, do it. Okay, I'm gonna write down the answer on board. Let's take a look at this guy. It's very clearly here. What is Px? Px is the coefficient of the first derivative, right? And here we don't have y prime. We don't have the first derivative. That means what? That means Px equals 0. Right? Very straightforward. Okay, so after you got Px equals 0, when you do the derivative, like I did before, right? So integral of this guy is a constant, right? So you just pick a constant 0, right? We just need a one solution. So you can directly pick c equals 0, okay? Then you plug in the formula here, right? So y2x and y1x and y1x is what? E to the power x. And here I said before that is 0, right? Negative 0. Here's a square, right? And we have e to the power 0 should be 1 over, right? And e to the power x. And again, you're going to get, and the derivative of this guy will be e to the power negative x negative 2. And it combines these two terms. Okay, x plus minus 2x going to be e to the power negative. So you find the second solution. Then we're going to do the linear combination. That's going to be C1. Right? Do the linear combination of these two. You're going to get this guy. It's the general solution. It's the general solution. That's it. That's it. Okay. Okay, so now we're already finished the section 4.2. Today we're going to move on a new section 4.3. 4.3. Homogeneous linear equations. with constant coefficients. Okay. An to the power n plus nth derivative, sorry. An minus 1, n minus 1, n minus 1 derivative until a1y prime plus equals 0, where the coefficients ai equals are real constants, and an doesn't equal 0. And we called this one as homogeneous linear equation with constant coefficient. So that means an minus 1, a1, a0 are all constants. Okay, there's nothing to do with variable x. We also have very special case. For example, we have a second order differential equation. We call it auxiliaries equation. Auxiliary equation. We consider second order equation. A double prime by prime cy equals 0. Okay, how to find auxiliary equation for the second order equation? Okay, for the second order equation, we're gonna use the substitution. Or we can use, hey, we're trying to find the solution, or we try the solution of the form y equals e to the power mx. Okay, we try this solution and then we plug in. Let's take a look what happens. Okay, so as we know, in the second order differential equations, we have second derivative and the first derivative, right? So let's try to calculate the first derivative firstly. If we do the derivative of this guy, we're gonna get emx. And then if we do the derivative of second derivative, so basically we're gonna do the derivative again, right? Okay, we got this one. Now we plug in. So we plug in, we're gonna get what? Plug in second derivative here. And the first derivative here. And y is cemx equals 0. Right? And again, we can simplify it. factor e to the power mx equals 0, right? Equals 0. And we can cancel divided by e to the power mx. So we can get this guy. Right? Now, how to find the solution of this guy? Then we have 3 scenarios. Basically, how to solve the quadratic equation, right? How to solve the quadratic equation, we're going to use a quadratic formula. But before that, we need to determine whether this quadratic equation has solution or not, right? Has solution or not. So let's take a look at the roots of this quadratic equation. And this guy we call the auxiliary equation. Sorry. We call this guy. Sorry, this guy is the auxiliary equation. Okay. So for this quadratic equation, we have 3 scenarios for the roots. The first case. Case 1. B squared minus 4ac greater than 0. Okay. If the b squared minus 4ac is greater than 0, what does that mean? We have 2 solutions, right? 2 solutions. We use the quadratic formula, right? From your college algebra. So we got one solution is negative b squared minus 4ac divided by 2a into 2 solutions. The second case, if this guy equals 0, what does that mean? This means this whole part equals 0. So we only get one solution. The third case. If this guy less than 0, okay. This guy less than 0, that means we don't have real solutions, but we have the complex solution, okay, complex solution. So for example, for the complex solution, we assume M1 equals alpha plus I beta, and M2 alpha minus I beta, okay? Alpha minus this guy minus beta. And the alpha and the beta is the real part and the imaginary part of the complex values, okay? So I think most of you guys already learned the complex number, okay? Complex number. So for this type, we have complex solution, and we assume the solution can be written down like that, okay? Solution can be written down like that. And then later I'm going to show you guys the examples. Now, for the first case, we have solution can be written down like that. If you find M1 and M2, we find the solution it can be written down like that. It's the solution of equation 1. Okay. For the first case, we found the 2 roots, M1 and M2. Then we can use this guy. Huh? We just do the linear combination of these 2. Or basically, we just plug in here. we have one solution e to the power m1x, another solution e to the power m2x. We do the linear combination, and then we're gonna get the solution for the equation 1. Okay, so the key part is find m1 and m2, then do the linear combination. Okay, linear combination e to the power m1x plus c2 e to the power m2x. For the second part, we can write down like that. Right? We can write down like that is the solution of equation 2. Okay. For the second case, we find the solution is this guy. Okay. And then for the third case, we can find the solution is here. It's a little bit complicated. We can find c1 e to the power alpha x cosine beta x plus c2 e to the power alpha x sine beta x. Or you can write down like that. Okay, you can write down like this way, or you can write down like this way. You just factor the e to the power alpha x is the solution of equation 1. Okay, so we have 3 scenarios. It's based on this auxiliary equation, and it depends on this quadratic equation. Depends on the roots of quadratic equation. If we have 2 solutions, then we can write down the general solution like that. If we have 1 solution, we can write down like this one. If we have a complex solution, we can write down like this. Okay, so let's take a look the one example. Okay, I still have 5 minutes. So let's take a look. Example 1. Right. And for this guy, we can transform it to the auxiliary equation. For the auxiliary equation, it's very straightforward. If there's a second derivative, that means m squared. Okay, if there's a first derivative, just write down m. Okay, and here is a 3. Okay, here's a 3. That's the things. All right. So here the a y double prime plus b y prime plus c y equals 0. So auxiliary solution gonna be a m squared plus b m plus c equals 0. Right? Like that. Second derivative m squared. First derivative m. If there is no derivative, just 1. C times 1 equals 0. Okay. So follow that strategy. We can easily write down the auxiliary equation 2m squared minus 5 minus c equals 0. Okay. For this guy, you can check the b squared minus 4ac. So b is -5 times 2 times -3. And you're going to get 49. 49 greater than 0. That means we have 2 roots. And you can use the quadratic formula. A is 2, B is -5, square root of 49. Okay, just plug in the b squared minus 4ac 49. And we have 5. Okay, and we can get the first solution, the second solution. is 3, right? 3. And to satisfy the first scenario, right? We got the 2 roots, then we can write down like this. So y equals C1 e to the power negative 1/2 x plus C2 e to the power 3x is the solution of equation 1. Okay, so that's the answer. That's the answer.